So first, I would like to talk about some basics about liquid metals. Then I will go to some of the typical liquid metal science, technology, industry, and then I will finally make a summary. So let's take a look at the what is liquid metal. So as everybody can see here, this liquid metal is in science fiction film. Of course, it is not true. It is just a fiction. Look at the lower part. This is actually the real liquid metal. It is running inside the supercomputer. Actually, that was made in the year of 2005. And the liquid metals can be like the liquid or some glue-like materials just on the upper right-hand side. Actually, the temperature in liquid, the liquid metal can be in a wide variety of temperature range, from very low temperature to very high temperature. Actually, the secret lies in the Professor Mendeleev's periodic table of elements. There are many secrets lying behind. That means we can make a couple of different liquid metals. The most classical is like the gallium. Let's see here, the element number is 31. And combined with other metals like yin or some tin, something like that, we can make more liquid metals, which is in liquid state at room temperature. But we can also say other liquid metal that, like the mercury. So it is very pretty heavy. Let me give you some more specific information about the liquid metals. So in this table, so we can watch a couple of very typical liquid metals. The most famous is perhaps the mercury. Its melting point is around below 38.87 centigrade. So this is pretty low. Of course, this is very, very well known. It is can easily seen in the thermometer or some reactors or something like that. Of course, liquid metal can also be made as alloy, like how to spell. This is sodium and potassium. This is an alloy actually. The melting point is below 11 centigrade, also very, very low. It's reactive, but it is useful. In this picture, actually, that was introduced into ablating the tumors in the year around 2009. It was also very useful, but reactive. And mercury is toxic, as everybody knows that. So at this time, what we want to emphasize, gallium in this table, it is very safe, actually. This is also the hard point in this day and age. So in this picture, we can see here, the liquid metal alloy, it's different kind of unconventional flow features. So like the above right-hand side, you can see here, the liquid metal can be driven to flow easily under electricity. And when it is striking in the airs, the liquid metal can be easily oxidized, just on the pictures. So this is just some of the very unconventional features. And the liquid metal can be easily induced to flow due to its pretty high surface tension. Even nanoparticles will induce liquid metal to flow. So in this slide, we can see here, the flow was just induced by the nanoparticles. So that is because the surface tension of the liquid metal has been changed in the solution. And if we use much stronger mechanical force stimulator, we can watch a kind of different surface waves. This is a very interesting phenomena, like the Faraday surface waves. But this surface waves is very different with the classical water because we can use the electrical field to control on or off the switch behaviors. So just to give you some basic information, if we put some of the liquid metal inside the solution, but leave part of to the outside, that means at the air solution interfaces, we can observe a very interesting phenomenon that is self-beating, just like a heart. So we can see here, that is because the oxidized process and the resolved process happens simultaneously. So we call this phenomena as a reason to harvest energy. Because liquid metal has many unconventional features, we can use the electrical field to control its behavior. So this slide shows that under the small voltage, the liquid metal can be induced to shoot, just like the droplet one by one. And the speed is pretty quick. So this is just because liquid metal has pretty large surface tension. So a slight electrical voltage will induce very unconventional ways of its flowing. And if we want to add some external nanoparticles inside the liquid metals, we have found that using the electrical fields, we can eat the outside particle inside. So what's here? The microscale particles, the copper particles and the nanoparticles can be swallowed inside. So this is a very interesting phenomenon. But it is not just a fundamental. It has very, very practical values. That means we can make much high performance materials. In this case, we can fabricate like very conductive electronic ink, mechanical, or some other very similar conductive materials. This can be used as a thermal interface materials. So some basic findings can be very useful. If we combine the liquid metal with some other polymers or some silicon oils, we can make thermally conductive but electrically insulating materials. So that means liquid metal can also be used as a liquid fillers. So this actually starts many fabrications of new materials combine the liquid metal with other non-metal materials together. So this picture shows that a very high thermal conductivity, but a very low electrical conductivity. This material is very important for some packaging. If you use a temperature to tuning the material, so you can find that under some temperature range, the liquid metal composite will become isolated. But when you freeze, the liquid metal composite will become conductive again. This leads to the finding of the conductor insulated transition liquid metal composite. And the materials is in liquid state. And the candidate is pretty wide. So I just give you some basic information about the science or some other applications. If you want to make the liquid metal beautiful, so you can just add some like fluorines particles with the liquid metals. This kind of material can also be used to make such as the biomedical channels. So it can be driven to flow inside the solution. And of course, liquid metals can be made very small, just like a tiny micro or nanoparticles. So this can be very useful in making a couple of different materials, very different functions. But unlike the classical rigid micro nanoparticles, the liquid micro nanoparticles made of liquid metal is transformable. So this is a unique difference with the classical nanoparticles. And of course, if we introduce some chemical reaction mechanism, we can find that liquid metal can be even made as porous structure, just like the biological lung. To see here, like these pictures. So such kind of material can float on the water surface. So this is the capabilities liquid metals offer to the technologies. And of course, if you want to make a liquid metal a little lighter, you can combine with some other materials like the hollow bubbles. You can make some lightweight liquid metals that can be also used for making some softer robotics, something like that. In fact, the liquid metal can be combined with more different material to make the liquid metal composites. Of course, the candy is too much. I just give you some basic information. And of course, the applications are diverse. But one theory issue I should share with you is the closure. These pictures, that is over the year of 2009, when we made some liquid metal chip coolings, we find that the liquid metal will close with some aluminum substrate. So this is very, of course, dangerous for some devices. So I share this slides, just want to make cautions that when we should be careful when we use the liquid metals to make different technologies. So far, a lot of very fundamental effects or phenomena has been disclosed on liquid metals, but I should say that this area is with endless questions or frontiers or something like these discoveries will lead to many very important applications. In this slide, I list several most typical applications developed over the past few years. The major directions is for the thermal management, as for cooling the chips or some systems. Another very important area is printed electronics and the 3D printing. And liquid metals, of course, is very important for making biomaterials. And of course, it has led to the making of some new generation software robots. In the future, more fields can be disclosed. So let's come to the applications. I will give you some practical examples. The first area is, of course, of using the liquid metal for cooling the chips, devices, and systems. So the primary is caused actually by the integrated circuits. Just as this slide shows, this is a very classical, also very famous Moore's law. It indicates the integrated density of the devices is increasingly become larger. So the chips and the things becomes very hard. So cooling is a very serious issue. So that's in the year around 2000, at the start of this century, I considered perhaps we need to find some new solution. Then we proposed the idea of using liquid metal for cooling device. So this slide shows a development trend of different kinds of cooling methods. That is from air cooling to heat pipe to water cooling until the liquid metal cooling. Unlike the traditional coolings, liquid metal cooling has its very unique performance because liquid metal would evaporate or boiling until 2000 centigrade, but water will evaporate or boiling at around 100 centigrade. That means liquid metal can sustain pretty large power and pretty hard chips. So this is just some of the prototypes we made about almost 15 years before. And some of the prototypes have received recognition by the societies. This is actually the earliest prototype we made in the lab for the computer chip coolings, this device. So this research has been awarded the best paper of the year award from the ASME Journal of Electronic Packaging at the year of around 2010. We noticed that at that time, more and more groups realized the importance of the liquid metal. And I'm very happy to say that a great many groups are joining into the liquid metal in different areas. And regarding the liquid metal, we have also make different thermal interface materials. Actually, such materials have been translated into the industries for some thermal management. And the application and the researches are increasing. We have been invited to write some book chapters and books for these areas. If readers are interested to read, so just try to check out. Another very important area is, of course, the liquid metal electronics. So far, it has become very, very hard in this area. So different categories has been made, and the many progress has been made. So this slide shows some liquid metal printed electronics. So it is very flexible, as you see here, and also some prototypes, also some products, as you can see here. And right now, I'm very happy to share with you that a lot of machines has been made and has been increasingly used throughout many universities and schools. So this actually the prototypes we had exploded to the China International Industry Fairs. That is the year of 2014. So this is two prototypes. This is also the first the world's first ever liquid metal electronics printer. So this picture shows that on the left-hand side is that this vice president of the Chinese Academy of Sciences. This is my student, also a CEO of right now well-known companies. This is a prototypes. And let me show you some workings of this kind of machines. So it's just the one word says future is coming. So this picture shows that the liquid metal printing can print what you want, hopefully in the future. But right now it still has some gradually developed, but in the futures, I guess more atoms can be printed out. And of course, we can make the liquid metal as a handwriting pen. So this was made in the year of 2013, and it has also been featured by the IEEE Spectrum. So this is Mr. Gibbs, he's the former editor from Scientific American, have read a story to illustrate the application of this kind of handwriting pen. And this kind of technology has also been used in some schools and universities. So unlike the traditional printed electronics, liquid metal printed electronics can be applied to any solid surface, just as our 2030 30-year study show that liquid metal electronics are made on nearly all different kinds of substrate, like the leaf, or glass, cloth, or even skin. So MIT Technology had a write a feature story about this breakthrough technologies. So right now, a lot of prototypes or machines have been made. So this picture shows the practice of liquid metal printers. Actually, so far, it has been increasingly used throughout the whole China, from very top university and to some vocational schools. And of course, the invention of the liquid metal printer has also received the recognition from the world. We are very lucky. We have to do some useful things for the society. So the award like the R&D 100 awards finalists, and also some popular science, most important technology, or something like that. Of course, liquid metal will be useful for some healthcare, just as I mentioned a little earlier. So right now, this is also becoming more and more very important. And we had also been invited to write a book on the liquid metal biomaterials on the sprinkle public health. So I will give you some examples about the applications and the technologies, or some findings, or something like that. Most of the people application is for making the wearable soft electronics. Just as this picture shows that, we can make the soft healthcare devices. It can help to monitor some physiological states of the human ears. Such kind of device can be printed on the papers, so that will reduce the cost. And the technology can be communicated with the mobile phones. In the futures, people can use such kind of technology to make more different applications. And if you want to use liquid metal to solve some very tough uses, liquid metal can also work. So this study shows that we can use, actually that was a very pioneering trials. We had introduced a liquid metal as connecting or functional recovery channels for the transected synthetic nerve. This technology allows the nerves to grow, but meanwhile, it will just help transfer the signal to the target tissues. So this technology received pretty wide attention throughout the world. So a lot of the very renowned science medium like the MIT Technology Review and new scientists have write stories. And we are still keeps working on that. Hopefully such kind of technology can help some patients in the coming time. If you, this picture shows that liquid metal can be used as a high resolution contrast agent. So let's take a look at here, the image on the left-hand side. So this picture shows limited liquid metal contrast imaging. And this one, figure B, is to use a classical imaging contrast. So we can see here, via the liquid metal injection, we can highlight very high resolution to show the structure of the anatomical structure. So this shows that the liquid metal is very helpful to realize high resolution imaging. The other images shows some of the organs, the whole bodies, or some of the applications. And of course, the liquid metal can be used for the major disease treatment. So this slide shows that we can use the liquid metal. So not just the pure liquid metal, it can be made as a composite. So such kind of injected material can be used to let's say here is in endovascular vascular embolization agent. That means the tumors can be starved to death. So let's take a look at this picture. Before injecting the liquid metal, the blood vessel just grows. But when you inject some liquid metal endovascular agents, the blood vessels will gradually damage. And if this tumor occurs, the tumors will gradually disappear. Of course, you can use some other imaging and some other semi-infrared imaging. You can get this same conclusion. And this happens in a very gentle ways. And of course, liquid metal can be developed as injectable electronics. It can also be used as a bone. This is based on different liquid metal. That is based on B, another low melting point liquid metals. So you can just inject via liquid state, but finally you will get solid materials. So in this case, you can make bones inside the human body. If you use this kind of materials to make some of the exoskeleton, you can get a reversible skeleton. That means if you want, you can have it in liquid. If you desire, you can solidify it, then you will make the rigid exoskeleton. Actually, this kind of technology has been used in clinics right now. I'm very happy to say that the patients will be happy with this kind of technology. This is clinicals trying to use such a kind of new technology to solve the tough issues. I think the last part I want to share with you is very interesting areas. That is liquid metal soft machines. So just as the slide shows that, so up to now, the most famous, also very advanced robot is Boston Dynamics. But we can see here, such kind of robots is still made of rigid materials. Let's take a look at the right-hand side. This is the animal in nature. So it's very powerful. So that means we still have too much space to explore. So that's why the liquid metal soft machines is arise. And it's actually started from the fundamental findings. So on the left, so that is first of findings. Liquid metal can be used, can be controlled to transform. So the world said such kind of liquid machines promise new era of soft robots. We've also been asked to write a book for this kind of material, but of course there's tremendous research are needed in the futures. So let's take a look at the basics about such kind of liquid metal. The first is it is programmable and under small voltage of electricity. Depends on the program, you can make different patterns, different behaviors, and the transformation is reversible. Sometimes you can rely on chemical or mechanical or some other facts. You can realize very complicated behaviors. And most fascinating behavior is a self-fueled behavior of liquid metal. Yeah, this has some music. This was made by new scientists using our videos. In this slide, we can see here, liquid metal is just running itself based on the fueling of the aluminum. So this is the aluminum. This kind of machines just self-powered without any other electrical or magnetic or something like that. So this is very fantastic phenomenon for liquid metal, such kind of very unconventional materials. And such machines can be used to realize some oscillators. So this is a liquid metal filled with aluminum. It can swallow the metal wires inside, but this would lead to oscillation, but not just a single direction movement. This oscillations, wire oscillation, its frequency and magnitude can be controlled by another metals. So this phenomenon actually is a total contribution for the material side, the solution effect, and also some surface tensions, and the mechanism is rather complex. If you want to make the liquid metal machines into tiny motors, it can find that. Such kind of motions of the motors, just like a spirit. So this is just the liquid metal machines, just here. So you can quickly make tremendous liquid metal soft machines. It's just running itself. It is self-fueled. Such behavior can be controlled on the external field. So if we use the electrical field to control, it will realize direction of flowing. See the left-hand side. So here, such a tiny machine will just run along the electrical field. So this will also reflect the electrical field distribution. On the right-hand side, this is the behavior of such liquid metal machines under the magnetic field. That means liquid metal machine is actually an electron with electrons. So under the magnetic field, the Lorentz force will play important roles to trip such kind of tiny machines. So we named this as magnetic trip effects. And then the readers may ask, can we make the soft robots? The answer is, of course, yes. So this slide shows some machines were made in the lab. Some of our students from electrical engineering materials can make different flexible machines. So it just transforms its shapes to realize different behaviors. Such material can also be made as sensors or some pneumatic actuation robots. And such machine can be even made as a jumping machines. That is based on the energy induced by the liquid metal. Liquid metal can quickly lead to the generation of hydrogen. If we ignite the hydrogen, it will realize very large magnitude transformation. In this case, it will lead to the jumping of the such kind of robots. So this can be very useful in some special cases. And of course, such material can be made as composite. Then you can make some programs. The program can be used to manipulate, to control such kind of composites. You can make some of the robots as you like. In the future, so different kind of devices can be incorporated in it to realize like moving, transform, or jumping, or some other interesting behaviors. But at this stage, I should say the liquid metal robot is still in its incubation stage. In the future, small completed robot will be developed. In this side, we had proposed the basic idea of using the intelligent liquid to integrate the functional entirety. In this case, we can make more complicated transformable robots, and the research part should be included like motion, energy, material, sensing, and of course, artificial intelligence. In this case, we can make very much like robots. So as the last part, I would like to share with you, I'm very happy to share with you, is the industries enabled from the liquid metals. So far, we have tried our best to help the industry to develop some very practical products. And right now, several big places like Beijing and Yunnan province, different areas, regions in China have launched the new companies, new industries, and quite a few practices. So this is a Yunnan province. Actually, this is the location where Liquid Metal Valley was located in. I'm also very happy to share with you that that is actually my hometown. So at the right-hand side, we can see here, this is just like a valley. This is very similar, looks like the well-known Silicon Valley in the US. But in Yunnan province is also a very beautiful regions, and it's very beautiful valleys. So this Yunnan province may be the most beautiful province in China. It has been named as a kingdom of animal, and also kingdom of plants, and also kingdom of the non-ferrous metals. That means we can find a lot of different metal candidates to make the liquid metal materials. So this is a very nice province in the future. I hope I can welcome you to visit my hometown and to visit the industry, the liquid metal valley established there. So far, quite a few China top university or vocational schools have been joined to build the liquid metal values, like the Tsinghua University and the University of Chinese Academy of Sciences. And a couple of research centers, labs, companies, and science museums have been set up in Liquid Metal Valley. There's already a lot of people frequently visit and to cooperate and to make some applications. These are just some very useful leading product lines for fabricating liquid metal functional materials and devices. And the devices are pretty much, if you get a chance to visit, I will be very happy to show you more in the coming time. And so far, a series of milestone academic conferences, industry summit, forum, and exhibition have been held in liquid metal valleys, and a lot of equipment have been exhibited. These are just some of the events happened over the past few years. And the technology has actually aroused big attentions and also generated big impact to the society. This is Prime Minister Li and the President of Chinese Academy of Science. Prime Minister Li is trying to use liquid metal handwriting to write some electronics. And this is Vice Prime Minister Li Yancao. He's take a look at the exhibition of the liquid metal technologies. And so far, a lot of very advanced liquid metal device has been translated into industry. These are some of the computer CPU liquid metal cooling device we transferred to industry in the year around 2008, and more prototypes of machines have been used right now. And such kind of technology has also been gradually adopted by the world companies. On the left-hand side is a Sony company from Japan. So they have introduced they have used the product from the China liquid metal valley. So they have used the liquid metal thermal interface materials for the thermal management of their PlayStation, and very high performance have been realized. There are other companies like LED from different provinces, and the different liquid metal products has been available in market, including some very top companies in China and also overseas. And some technology in healthcare also increasingly invented and application applied. This is a wearable exoskeleton, and quite a few different prototypes, different cases have been invented and increasingly used in the clinics. So I think I need to summary to conclude my talk. So just as one word saying that the human civilization has inspired us, that is one generation materials means one era. So in this case, if we use the metal to define the history, we can have the bronze age and also iron age. So can we ask such a question? Where liquid metal age come? So let's expect. I think that depends on the world cooperation and also research, a lot of efforts in the coming time. So that's what I wish to share with you. Thank you very much for your attention.